Hello, I'm John Chivacco, the co-chair of the NY-GEO 2023 conference and a board member of the New York Geothermal Energy Organization. I'd like to welcome you to this recording of a live presentation from the conference, a two-day event which was held in Albany, New York on April 26th and 27th of 2023. This year's educational sessions and keynotes represent the latest in ground source heat pump system design, product innovations, and installation practices, along with important policy, regulatory, financing, and incentive updates. This presentation is one of over 40 sessions from the two-day event, all of which were recorded and available at NY-GEO's website, www.ny-geo.org, along with session descriptions and a link to download the slides from each of the sessions presented. NY-GEO is proud to make this content available to our members and other industry stakeholders, and if you are a member, thanks so much for your support and participation. If you find this content valuable and for some odd reason you are not yet a member, consider joining NY-GEO at the appropriate membership level with details available at our website. The live recording from the NY-GEO 2023 conference will start in just a moment. Thanks so much for listening.
So the 500-foot rule, easier said than done. What do we need to know about going beyond 500 feet? I've heard two phrases thrown out here during the course of this day-long panel. Deeper is cheaper. And I've also heard deeper is never cheaper. So there's clearly a couple different opposing views. And it's a very important topic in the state. We have currently, just so everybody's aware, anything deeper than 500 foot in New York State requires a very heavy, involved permit process. It requires a individual permit per bore. It's not per bore field. There's all kinds of data logging and registrations that you've got to go through. I've never actually done it. Yet if I want to drill a water well to 800 feet, I can do that. And it happens regularly in different parts of the state. We've had geologists up here today, and I'm hoping that we get a lot of good questions from the audience, and we'll probably see more people file in as we go through this. There's a lot of considerations that we have to have as we explore this topic. And we've got a couple good individuals. Stan, you've been up here almost as much as I have today. I appreciate it. And then we have, do I get a mic going? I'm going to let Mark introduce himself, and we'll work from my right.
That on?
There you go.
Mark Metzner from CDM Smith. Operating in Canada and the United States. Been involved in the industry for about 20 plus years. Lots of deep boreholes. I think they're the way to go, but Stan?
I would agree.
We're Canadians.
We're Canadians, yeah, that's why. So, no, just kidding.
Is that with the conversion rate or without?
Everything's discounted 30%.
There you go.
I'm Jeremy Baldwin. I have a degree in hydrogeology. I'm a master groundwater contractor, and I own Hawk Drilling Company. And I don't think 500 feet is necessarily a good thing in New York State across the board. I think it's more of a case-by-case thing. There's certain areas where maybe it makes sense, big commercial jobs, other areas where it makes terrible sense.
Tyler Wills, Smith Well Drilling. We're residential and commercial water well. We're only about 20 minutes south of Albany here. We've done a fair amount of geothermal in the past. I'm going to agree with Jeremy. 500 foot is plenty.
So I think a lot of the things that we want to talk about as we go through this, we've got some people on this panel that have drilled deeper than 500 feet. There's a lot of people across the world. You know, to be honest, we've seen a pretty international flair to who's been up and had a hand in our conversations today. And I've got a couple questions that I want to throw out and get some perspectives on it. First and foremost, when we're talking about drilling and doing something a little bit different, we need to talk about safety. And we need to talk about what types of things, rules, safety measures, do the guys that currently drill deeper than 500 feet, what are they? Why do you use them? And how can we apply them to New York State as we move forward potentially?
Yeah, so most of my drilling is in Ontario, Canada, so Toronto area particularly, and we have the same issues that New York and Michigan and most of these places with a lot of glacial tills, of course, so you have deal with overburden. So that's part of the reason why going deeper sometimes makes sense. Once you've drilled casing in, it's often cheaper to just keep going once you're in the rock. So that's one of the reasons why we're seeing one of the reasons for the depth. Safety, it's probably a gas issue is the main one, and of course the deeper you go, the higher the potential for higher pressure gas. So that's probably, you know, the reason. From our perspective, it's whatever safety, like we were required, of course, to have some gas safety measurement and diversion of gas away from the rigs and so on. Our view is if you're going to do that for 800 feet, you probably should be doing that for 500 feet as well. Not necessarily everywhere. I get that it's not always an issue and you know your areas. But if it's an uncertainty, you're probably running that safety gear anyways. So I don't see a lot of difference between, say, 800 feet and 500 feet in that regard.
I think just to piggyback on what Stan's saying, I mean, the safety issue is, you know, paramount for everyone. You know, you don't want to be blowing up neighborhoods. I think you don't want your personnel going home at night. Back to what Jeremy was saying as far as, you know, 500 feet may be, you know, okay. I tend to agree and disagree, which sounds kind of stupid. I think it's very site specific. What does the site give you? So you can have an engineer say, yep, I want 850-foot boreholes if we weren't in New York. The site may not give you 850s. You may find that the sweet spot's going to be 450. So I think you have to let the site dictate a lot to what's going on. You don't want to put the square peg in the round hole. So I think it is, you know, dictated by what's sitting in front of you. We don't know geology as good as we think we do, and we encounter something a little bit different with every borehole we drill. Water production can, well, Stan, I mean, you know about water production, it can kill you. So, I mean, you don't want to be pushing, as they say, poop uphill, right? So, but going deep has its merits. When you have a very tight spot, or, pardon me, site, you want to maximize what you can get into that site. Going deep makes sense, but it has its pitfalls as well. You're going to have your bit wandering back and forth. These holes do not go down gun barrel straight. People think they do. They do not. They can wander over and hit the neighboring borehole. There are inherent risks going deeper, but they can be managed. Stan's drilled thousands of boreholes. Has he hit the other borehole on a project? Sure. In the big scheme of things, is it a reason not to go deep? In my view, no, but Stan?
Yeah, so I think the question's on safety, so I presume you're touching on some of the other things here. So, but yeah, so I've got nothing.
I have a whole list.
Yeah, so I'm gonna hand the mic over.
Yeah.
As far as safety goes, I mean, as far as right now with what most drill rigs are set up for in New York State, I mean, on a commercial job, we were talking about this earlier, you know, you would have to have a skid of extra rods in there. Most of the rigs are set up for 400 feet or less. And as far as putting in a loop with a hydraulic looper, I mean, you have an 800-foot empty hole. There are safety issues with that when you're installing the loop due to the weight, because, I mean, I'm not an engineer. I mean, would you need bigger U-bends in there, or would you still stick with like 1.5 inch? And as far as the safety versus of the gas, yes, we do have to worry about gas in a lot of areas less than 500 feet. But when you do get beyond 5, in just certain areas, I mean, there's areas where we don't have to worry about gas at all, and then there's areas where we have to worry about gas. And the other thing, safety for the aquifer, we have very, very high chloride, high TDS salt waters deep in the shales in western New York, and we know that these salts break down the bentonite. It doesn't swell properly. Maine is having an issue right now on the coast where the salt water are washing, as the tide rises and falls, the water table rises and falls, and it's washing the grout out of some of these wells, and they're seeing some subsidence and leakage out of these wells. So could something like that happen on some of these deeper holes? I don't know.
I think I'll just back up pretty much what Jeremy said. You know, most of the safety issues I see are with the drill rig, as far as they're set up, you know, 500, 400, 500 foot or less for the most part. Eastern New York, you know, state border, there's not a ton of deep gas. Western New York, there's a ton of deep gas. You know, New York is a major natural gas producer, or could be. You know, I think just a broad base, you know, hey, go deeper on everything, I don't think fits. I do believe, you know, commercially in urban areas, I think it's got a good fit. You know, again, gas, just bigger equipment, you know, heavier loops, bigger reels, you know, and running 1,000 foot. If you break your top head chains at 400 foot, or you break your top head chains at 800 feet, there's a lot of damage in between there.
So I know there will be questions. Maybe I'll answer some as we go through. But you guys kind of touched on it a little bit. So as we look at it going deeper, how does grouting change? Do you changing the mixtures? Are you seeing any difference in how you pump it? Bigger pumps, still positive displacement through a tremie?
So the move to graphite grouts has made deeper holes more possible. So we started 300 feet with polymer and bentonite, so your bend seal with the easy mud mix. If we could do 300 feet, we were doing well. Then we moved to geothermal grout, which so there's a number of, you know, just geothermal with sand, silica sand, and doing. We typically hit about 200 pounds, and after that said, you're not going to get much better than that because we won't be able to grout the holes properly. But then 600 feet was about the max with the, you know, say a geo loop with the typical. But now with the graphite grout, 850 foot holes are quite doable with the same pump. So it has the grouts have improved. The ability to place it. I don't think I'd want to try to pump sand grouts through 800 or 1,000 feet of tremie line. So, but yeah, that's my experience.
I don't know that anybody misses sand grouting, to be honest with you. So what about things like, I know New Jersey, you have to use cementatious grout. And we have saltwater concerns and gas concerns, and normal bentonite grout doesn't hold up to that. Have you used cement-based grout in deeper boreholes? I'm going to pick on these guys in a minute.
Yeah, so yes, we're using that in at One Java in Brooklyn, and it is a GeoPro product. So it's basically geo product with cement added to it, and it's now those are 500 foot holes. So, but it's quite workable. It's not a lot different than running, you know, just with graphite and bentonite. So I would say you could go deeper without too much issue with cementatious grouts. The only issue is they're a little heavier, and so you end up with more, and they set up a little slower. So there's more loss.
Do you have to add plasticizers to that?
I don't know if Nigel's in the room here. I don't think so. I think whatever's in the mix is already works.
I think that they have some stuff in there, like GeoPro, their grout has some plasticizers in it, I think.
Yeah, then I know that Setco has a product, Sea Grout they call it, which is also coming out soon, which is, we've done some testing on that as well, and it worked not too bad to use with deeper holes.
I think when it comes to the grout, we have to really give the grout manufacturers a lot of credit. They are incredibly, where are they? Where's our, there we go. No, I mean, they're very innovative. They're understanding our issues and the environmental concerns. And I mean, they're just a marvel to work with. I was on a job last week, needed to have a different mix because of pumpability. I was on a phone. I got the submittal on my phone in about a minute and a half. New mix, this is going to be the same K value. Here's a different way to mix it on the pumpability, and it worked. So my hat's off to the grout guys, and as we encounter more and more issues or regulation, I think we have a great partner to rely on there, and they are just a marvel to work with.
So now I'll pick on the drillers. So historically, New York, a lot of family-based businesses, a lot of generational businesses, typically slow to evolve, slow to change. We're all guilty of it. You guys probably remember, 15, 20 years ago, you'd go out and you'd put in a 3/4 inch loop, you'd drill 5 or 6 holes, and you'd call it 3 days. With the changes to going to just the 500 foot, has that been a benefit to your businesses? Single borehole design.
Yeah, we would single borehole 500 foot. The goal is do it in a day, one a day, get it done. But yeah, we did those jobs, 3/4 loops, and we were there for like a week on like 5 3/4 loops, and we were pumping, hauling in sacks and sacks and sacks and sacks and sacks of sand and everything. And there was no room, it was a little bit of a disaster. But and the 500 foot single, it does work out well, and with no waste and everything too. We're not seeing much waste. You drill it, you set it, and you go.
Yeah, I know. I mean, most of the stuff that I've ever done has been 500 foot. You get the occasional 300 footer or something like that. I mean, 500 does seem to be the best bang for your buck efficiency wise, stuff like that. You can get it done in a day, you can get it looped, you can get the rig moved, get to the next one, whatever. Because most everything is on the machine. Your 500 foot, you're tripped back on the machine, it's in the carousel, you lay it over, you're done. You get down to 800 foot, just, connection time between rods, as you go deeper increases. It's longer to get that air pressure built back up in that stem from, 0 up to 350. You got a 700 foot string. Your efficiencies just keep falling as you go deeper. And there's ways around it, but once you set up for it, but, again, residentially to go everyone to set up, with check valves and all this stuff, it just, you can do it, but it's not the blessing, you think, hey, you're saving time. There's definitely some drawbacks to it, and 500's been worked out to a science, I think, to be a pretty efficient point.
So, because I think, Stan, maybe you talked about this earlier, there might have been somebody else that talked about it, touching on that building air pressure. Was it you that talked about changing to water or different drilling methodologies to overcome some of those issues? How big of a change was that for you and your company to adopt that in order to go deeper?
Yeah, so the water drilling is called water drilling or mud drilling. There's a couple reasons for it. One is you can drill in situations where there's an awful lot of groundwater fractures, that type of thing. You don't get the airlift that you're getting with air drilling, so you don't get returns. At least you don't get hundreds of gallons of returns that you got to deal with. You're recycling and you're adding water to your system as opposed to trying to get rid of water. So that's one of the reasons. Yeah, there's some ancillary benefits to drilling with water, but I think the simplicity of drilling with air, having an air compressor on board, especially for residential drilling particularly, I can see having a mud system and air drilling and all that kind of stuff, having to show up on site is going to get a lot. So that's to me, the water drilling probably has applicability in commercial side more so than smaller projects. But that's, you know, it will work. It's just, can you bring all that
It will
gear?
work, and it is work. It's just, yeah, there's changes to it. So in the room, we have a whole bunch of different classes of designers, developers, manufacturers for both heat pumps and drilling equipment. How many people in a commercial setting would see a benefit to going deeper than 500 feet on a consistent basis? How about on a residential basis? Okay, much smaller number of hands between there. For the drillers in the room, we'll start with you guys. If you're being presented with a project, because part of what we're being tasked with is how do we grow the industry, how do we get more people involved with doing geothermal, how do we get more projects out there to bid? If you're being shown a project where you know the geology, you know the conditions, you can have the equipment on site, would you drill deeper than 500 feet in a commercial setting?
I guess it all depends on if, you know, we know how well we know the area. And that being said, in the geothermal industry, and well drillers are the ones that end up taking all the risk when it comes on the site. Engineers can say it's a workout, but we end up having to be the ones that have to figure it out. We work with them on the end, but we have to be the ones to figure it out to make it happen. Dave Rosick had 100 gallons a minute flowing over the top at 400 feet in an area where there wasn't any room to get rid of it just this week. It's just one of those things where if you really, really know the area, sure, you can go for it. I mean, in commercial applications, gas monitoring, like Midwest had said, try to figure it all out. But what you definitely don't want to see is this come through from the commercial side and roll its way into residential in areas where it's bad engineering and bad business to do it, where we could be damaging aquifers and things like that. And because if you get residential guys who aren't as good, they don't have the experience and they're jumping on the bandwagon, you may have these holes that don't get grouted well. Because the way this is trying to be pushed through, they want everything to happen fast. We want to train people fast. You're going to have people that aren't good trainers. You're going to have people that don't know really what to do, and they're like, oh, the grout line stopped at 600 feet. Send it, and we're pumping grout, or we're pumping regular, you're pumping PowerTech and GeoPro Light, say, and they're pumping it down the hole. They got another 200-foot hole underneath, and it's just washing out, and it's washing out, and the bottom of the hole isn't grouted properly. So it's a case-by-case thing. I mean, I can see where it's done commercially, but like I said, it would have to be, almost some standards would have to be put in place.
Commercially, yeah, I would. I mean, if there was a test hole, you know, urban areas, tight spots, stuff like that, you know, if it makes a difference going deeper to get on, you know, like 20 or 30-foot centers versus 15s or 10s with shallower holes, then there's an advantage to it. You know, if there was two projects put in front of me, both with 20,000 foot of drilling, one was 500 footers, one was 800 footers, I'm going to bid on the 500 footer a lot more aggressively than I am the 800 footer. So.
What if it's 200 foot to rock?
I didn't get that email.
I see that.
So I'm gonna start opening it up to questions, and ultimately I think what we're trying to get to is there's a need for it, there's a time and a place for it, it's already being done, it's at this point about communication, it's about understanding geology, it's all of the things that we've kind of talked about leading up to this, and it is a tool in the toolbox that our industry needs to grow to meet the state standards. AJ, are you going to be my mic guy?
Kevin, just make one comment.
Go ahead.
Yeah, so Jeremy, just back to what you were saying, and I fully appreciate the risk involved on drilling. I mean, we all get it. We don't know what's down there. A decent test hole with a decent log, I agree, but you want to have that third party verified. You don't want to take another driller's word for it. We know how this works. But more importantly, I think, is when you're looking at commercial jobs, and they're large, they're going to be in the hundreds of thousands or millions of dollars, and you're probably not a huge corporation, so you don't want to take on that kind of risk. My strong suggestion, though, is these contracts have to be well written and well understood, so that the risk that you are potentially taking on is mitigated to the point where you find it palatable enough to bid. But I think there's going to be a huge amount of commercial jobs. Should it change here in New York for it to go beyond 500 feet, you will see those 800s, 850s, who knows, it could be 1,000. Like I say, my strong suggestion is to get your contracts language fully understood, so that a developer is not dropping all this onto you, right? But I mean, they're notorious for doing that, and it's your diligence to say so far and no further. It's, you don't want to walk in blind. That's where you'll get squished. So,
Sounds like another place of shared resources. A lot of experience out there. Same way as we're trying to share more drill log information, more drilling information. Something to keep in mind as we go through.
Ago with DEC, they specifically told us that we are not going to go down the road with geothermal in New York. That's a separate entity. It's a division of oil and water. And the reasons being is that they had deep concerns because we're pretty much underlined from the thruway south and from Buffalo all the way to Albany with shales. The shales are loaded with barium, heavy metals, radon, arsenic, high sodium levels. They're very concerned about interaction between aquifers, upper waters communicating to lower waters, vice versa. And again, almost 50% of the people in New York State rely on some source of groundwater for their source of supply. And the same with these salt waters and these concrete-based grout. There's no acoustic testing goes in to guarantee, and who's it going to fall back on? The liability is going to fall on the contractor. And with concrete grout, you get the George Costanza syndrome, shrinkage. And
Say that again?
I promised my nephew I wouldn't say anything out of order, and that's probably not very good. So, but right, the grout studies have shown when we have concrete grouts, we do get a certain amount of shrinkage. So I don't know with the bentonite additives if that would hold true. And so yes, we don't. The people from the Division of Water, I don't know if they've been involved. Kevin, do you know? Have there been ongoing talks with them regarding the deeper drilling? It can be done under permit and under bonding right now, but they have their concerns at DEC.
I mean, it's a big topic of conversation. It's one of the reasons, again, why we want to bring together all of these stakeholders in this room to try to create the best plan, the safest plan as we possibly can moving forward. I can't say an awful lot more than that, but go ahead, Rich.
So the thing that always catches me is we're starting to get into the crossover where we're getting into the gas well drilling area. And what we do when we start a hole, I don't care if the bedrock's at 10 feet or 200 feet, we don't have control. And that's a problem. So if you drill an 800 or 1,000 foot well and you multiply that by 0.4, there's your potential. That's assuming you don't have any other kind of connection deeper. And you have no cementing up top. And is there going to be control to hold that upper casing in place with your diverter? Because if you have 400 PSI, and maybe it's only, volume-wise, it's only a short period of time, maybe it's overnight, but there's not a lot of time to react when that goes. And then you're outside your casing. And if there is volume, you have bigger problems. I want those who are designing and thinking about going deeper in New York State. We run into gas all the time. Of course, maybe I'm a little gun shy because we lost a rig. but I know 3 or 4 other people have lost rigs for the same reason, and it doesn't have to be 400 feet. And it doesn't have to be 1,000 feet. So in those regulations and things that you're looking at, and places where you wouldn't have expected or anyone has actually drilled, except maybe for some of the gas industry, and there are resources to be able to go through, you know, mining in the DEC, and people like Joe Yaris, who knows very well what central and western New York is like. But there's risk there without control. And I personally, you start getting below 500 a lot, and you don't have control, I think you're putting a lot of risk in.
Hand it back to where it came from.
Just coming back to this comment about 400 psi, does it really make a difference? You get 200 psi pressure or 400 if it's gas? I mean, if you don't have controls on surface, you basically, your rig will burn. Doesn't matter you're at 500 feet or 1,000 feet. So if you have such kind of risk in terms of gas in these areas, then you probably need to change approach in terms of well delivery. You need to probably set the surface casing cemented, make sure you have a diverters, make sure you can close the wells, switch to the mud systems, so you can basically pressurize the well like we do in oil and gas, correct? So the way to control the fluids, you basically need to create the hydrostatic pressure. And in this way, it doesn't really matter how much pressure you have down there, you can always control from surface. So if the gas is really the reason for this, then basically you need to adjust the technique.
So our experience on the gas side, and I think what you're asking, some of those controls need to be there. Our experience would be, do not shut gas off at surface, unless you obviously have cemented casing. But even then, what you're not asking is, do you really have what you have in the oil and gas sector of, you know, you got your casing to rock, and then you've set a bunch of, you know, mid-string also cemented in, and that's your control casing. You would need more than 50 feet, and then you drill into fractured rock below that. Your gas is popping out all over the place anyway. So I think the key here is, of course, control at surface, but not necessarily off at surface. And there's a big difference, right? And so rigs getting burnt up because gas coming up, there is a pretty easy solution to that, and that is diverters and making sure that gas is actually getting away from the rig, not right next to it. So, I mean, that's a pretty, you know, that seems like a very simple option. Getting into cemented casing and all that kind of stuff is a whole other thing, and especially if you got retrievable casing like we're running, cementing casing is not an option. We're not creating wells, we're creating boreholes, which we keep talking about wells here, but these are boreholes. They're temporary, so we're not trying to build something that's going to last for 40 years in terms of well infrastructure. We're trying to create a loop, and there's some real important aspects to how we construct to have safety during drilling, and then completion in a way that is now safe from a gas perspective long term. So making sure that there's nothing in there where we can leak gas up around an annulus of casing that's not grouted in, for example, which would be quite common with casing. So these are, you know, well taken points though, but I think there are ways to be reasonably safe without some of the high level controls that we're doing and that are being done in the oil and gas sector.
Yeah, I was just going to add, you know, when I believe, and it's been a while since I did a couple, but when they were doing oil and gas wells, shallow stuff, generally they run 400 to 500 feet of steel casing in, and then they want that cemented to the top. Kind of goes back into the, you know, 500 foot, they're shutting off fresh water, sealing everything off. Back to the 500 foot rule, you know, once you get deeper than 500 foot, your chances of getting big gas or whatever are greater and greater and greater. When we drill a water well, if you go 800 foot and you hit gas, as long as you don't burn your rig down, you know, the well might bubble a little bit. You get some methane in the water. You're not, you know, trying to cap this and close it off and not going to really create environmental hazard. You drill a deep geo hole, don't grout it right, you know, get a big gas formation, get the thing sealed off at the top, get out of there and think it's gone. You know, are you creating more avenues or more potential for, you know, this gas to keep mingling to the surface, because there is no cemented surface casing. There's no, you know, barriers of protection. So if you're going to go deep in those areas, are you essentially saying, you know, put all those, you know, put a 400-foot string of cemented surface pipe in there?
Go ahead, Dave.
Yeah, I'm loud. I did a lot of work from starting my career in downstate area, you know, Long Island, sands and gravels, no gas, hard schist, you know, granite throughout New York City, up into Connecticut, no gas. Heard of a couple stories about people working in areas where they're like pulp mills and, you know, contaminated areas, landfill, there's gas. But most of that stuff is documented when you do your due diligence. My company now, we're expanding, and we're talking to people around the state about opportunities. And I open up my maps as soon as I talk to somebody about an address, and I look at the Marcellus shale splay, and I'm like, I don't want to go anywhere near that. I don't even want to talk to this person anymore because I don't know anything about that. And I don't know if it was Jeremy or Tyler that mentioned, you know, people up at DMR that like know this stuff. Like, is there any, you know, the people in the state? Are there people with institutional knowledge that drillers go to that they look at and like, hey, do you know of any, like, you know, mapped areas, or is this like borderline? Is there a resource for people that we can go to in the state of New York? Because my experience has been this rule, they do it, you know, wherever you are. You know, you could be in Manhattan. It's the same rule. You have to, you know, embed casing 50 feet into competent bedrock, use a Halliburton plug, and, you know, grout up the whole well for a geo well. And to the point, you know, Dimitri, you know, we're getting pressured. Put in a geothermal loop at $15 a foot. You know, so are there resources for us like that you guys know of?
Some water wells been recorded since 2000. You know, back to
Not quality though.
not quality or anything like that, you know, just depth to bedrock and geologic strata and stuff like that. You know, gas-wise, again, commercially, where geologists are involved and stuff like that, there's probably a lot less of a risk. Residentially, where it's like, hey, run over the 23 Albany Ave and go hammer into 900 footers. You know, we helped plug a well for a geo hole just up in Saratoga, up around Saratoga Springs, and some guys got down 450 feet, and I got the video, and it looked like Spindletop. They hit carbon dioxide and gas and salt water and everything gushing out of the rig like the air was on.
There was almost
And
so
there
much
was-
carbon dioxide you couldn't breathe.
Yeah, you know, and this is at 450. Nobody knew about it. Nobody expected it. I've never seen it before in my life. I'll never see it again. Jeff the same. You know, we were both up there. Yeah, yeah. I mean, it's right down the road from his place. You know, that kind of stuff can happen. No, there's not a lot. There's just not a lot of knowledge there. And the one thing I do want to say earlier about the grouting and gas coming up, grouting properly, I don't see an issue with deep holes or anything like that. It's more of somebody gets gas, slams the loop in, covers the top up, gets out of there, and now your pond is spicy.
Yeah.
Go ahead. No.
And we were lucky we were able to get that water. They had a silt fence, they had a sandbag as best as they could. We were able to get the water to run away, and they hit a void at 450 feet, and so they were working for an installer. The installer says, you know, well, what are you going to do? Well, we got to shut this well down. They were able to put a plug in it, and then that slowed the flow to about 100 until it started weakening around the plug. Then we put a mechanical pack, no, we put an inflate packer in there, which is over $9,000. Point being, the well driller spent out of his pocket $20,000 plus, lost the hole, and we mitigated a serious mess. Point being, the customer of the house says to the well driller, well, where are you going to drill the next one?
Just a quick comment. Just a quick comment on this. I mean, it's interesting. These were all sub 500-foot holes.
Yeah, 450, that one was.
So where I'm going with this is 500 feet, and I'm from Canada, so that's my excuse. But we have the same thing up there. The 500-foot rule here in New York, we have the same in Alberta. It seems to be very arbitrary. Somebody somewhere at some point in time said the magic number is 500. Why isn't it 400? Why isn't it 600? And shouldn't it be much more specific to the geology and whether you hit gas at 200 or you don't hit it at 1,000? It's the geology that should be dictating what you're doing, not a arbitrary rule. And so, I mean, I think going deeper is appropriate where it's appropriate. And when it's not, don't do it.
Well, and that's just it. I mean, you've got such highly variable geology, and you know, there's however many, 1 million water wells in New York State, I believe is your number. Most of them are shallow. And now we're slowly going deeper. We're encountering things that we haven't seen before. I mean, we've got well logs going back to the 40s, 30s, and you show up to do a geo hole for that, and it's just, you don't know what you're going to see. You know what you're going to see the next time you show up, maybe. It changes, you know. Everything that we talk about with geothermal, a single bore field of 100 bores changes from one end of it to another. You know, it's trying to have a good, solid conversation to set the path for the best chance of success for the industry, be it a mix of 500 feet, 800 feet. I don't know if there's a correct change in that arbitrary number. I don't know that anybody does. It's an interesting problem, without doubt.
If I ask you that you don't have geological problems, for example, you drill exploration wells with all safety stuff in place with geology, basically bypass all the garbage, how much deep you can go? Like physically, what is your current physical limitation?
What was that a question? What's the physical limitation for how deep we can go?
I've drilled to 1,860 feet. Oh, I forgot about the hammer, so it was 2 feet. And on that one, we cemented casing into rock and everything. It was all stainless steel casing.
That was cheap. And that is one piece of this, as we continue to try to push this envelope to get more projects, more sites eligible to put geothermal in. There's always this push. Can we do it? We can. Can we do it for cheap? I don't think so. Especially not as you want to try to scale and grow. We are getting into a position of highly skilled, highly specialized, highly caution. Lost my train of thought on what word I wanted to use there. We want to be safe. You know, we want to be able to complete a borehole every single time. A lost hole on a commercial job site out of 100 bores, it stings. You lose a bore on one job site in your residential market, that can hurt. That can almost bankrupt some small businesses. Any other questions?
I'm curious if any drillers here use gas testing as your normal while you're drilling. We do not, and that is my husband, and I constantly worry. He has set the drill rig on fire, and we do get gas pockets. We had one recently where it was 30 feet is where the methane was coming.
Yeah, no, the one of the 30 feet, that was a steward's shop, and it was contaminated with gasoline. Yeah, no, but no, we don't do any testing. And actually, the one time that we actually had methane fire, it was in the overburden. We were actually setting casing, and it ignited while we were setting casing.
Oop. Who's got it? Sandra?
Yeah, I mean, one thing is listen to your wife at all times, of course, even if she's right.
Dave, and then
She always is. Okay, so gas detection obviously, in my view, should be done at all times. Now, unless you're drilling where there is absolutely no gas, but it's just one of those things. The other comment I did want to make, though, talking about drilling deeper, is I would not recommend anyone to go drill in an area they've never drilled before, including me, to depths that I just am not familiar with, starting with, I'm going to go to 1,000 feet today because someone wanted me to drill 1,000 feet, and I thought, yeah, the rig can do it, you know, but I've never drilled here before. So I have this argument. In Ontario, we have the Ministry of Environment, who are really fun to deal with, and one of the questions that keeps coming up, well, how do you know you don't have a problem? I said, well, I think part of the thing we know we don't have a problem because we've drilled thousands and thousands of holes in hundreds and hundreds of sites around here to those depths. But we didn't start at 850 feet. We started at 200, and then we went to 300, and then we went to 400. And we progressed until we got to a point that we were very comfortable with 850. And if you ask me, should we go to 1,000, I'd say, well, I'm probably going to go to 900 first, get used to that a little bit, and then go to 1,000. So I think part of this is a progression, and in a comfort level and a gain of expertise. I think you were talking about that transition between, you know, residential and commercial work. Part of it's just the capability of the people, the training they have, the type of gear that they're running. All those things are part of this conversation because we've seen it in Ontario where the push to go deeper has caused problems with someone who was not ready for what they came up against, and it causes a lot of problems. And that was really sort of and we looked at it when we drilled there before, it's no problem, but it's just because of the lack of experience it was caused problem.
The only thing I have to say on the whole 500 going over, I think it is site specific because there's a lot of the residentials we have, you could barely get the rig in there. Never mind, you know, and our rig holds 520 of steel, so 500, you're right there. 6, well, not too bad. You only got to get a few rods off the other truck, getting them in there, and so it's really a lot more work. In our loop roller, I can't imagine a 1.5 or 2 inch loop. That's 1,000 footer, so you got 2,000 foot on the. So we'd have to change that. We have to change our grouting wheel, bigger. So there's a lot more to it than just throwing a few more rods on and going. So I think that's all got to be taken into consideration when they, you know, when you bid this out or do it, you know.
I think Heather has a question, comment. And we have about 10 minutes before that magic trick.
So I'm curious, within the context, say, for the state of New York, about 8 million homes, 3 million single-family homes, all of them need to go onto heat pumps. The state climate plan says 1 in 4 of those should be geothermal heat pumps. So that's 750,000 homes, single-family, that need residential geothermal heat pumps, and I think there's on the order of 1,000 or a couple thousand so far installed in the state of New York. What would you all want to see in terms of the mix of how much of how that happens is determined by the industry and industry standards versus regulated? Like this 500-foot number is arbitrary, right? Could have been 450, could have been 600, it's 500. But as and when those are adjusted, and you know, as Kevin intimated, like those are active conversations, like what would be helpful to have be regulated by the government versus by industry standards, industry associations, by your own business decisions?
I'll throw into that real quick, if you don't mind. I think it's been mentioned a couple times, even Stan with Canada and these guys and Dave and we've all of us that do projects. The site dictates, the geology dictates. You know, it can't just be we want to pick a certain market, in my opinion, and say that this is where it's going to happen. Let the geology tell you what you can and can't do, and that's a industry-wide conversation. That's a huge collaboration with people that have gone deeper, that have seen the issues, that have developed the scar tissue. And my opinion is every site is possible for geothermal. Let's find the ones that make the most sense and then go from there.
Just a quick comment on the depth and so on and so forth. I think the flexibility is what's required. Geology, as we've been saying, dictates what you can and can't do. Doing single-family home retrofits as an example, I think for the individual drilling firm in a particular area, they should have the flexibility to do what's going to work and work in collaboration with government, make sure that they're comfortable going deeper if that's the order of the day. So it's not a one-size-fits-all. Cookie cutter doesn't work. People love a cookie cutter. It works in fantasy, doesn't work in reality.
Yeah, I think, commercially, there's a big difference between commercial projects and residential projects. From the engineering, from the, time, from the funds, from the space. Even a small commercial job is usually substantially bigger than a residential job. Commercially, yeah, there's definitely a time, a place to go deeper. There's going to be safeguards, there's going to be test holes, blah, 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 blah. Just a broad base, go ahead and as you're designing systems to say, oh, hey, we got the ability to do 800 foot, 900 foot, instead of doing 2 4s, thinking, oh, we're going to get all these great bids on one 800 footer. From a, driller standpoint, no. Residentially, just across the board, 500 foot is plenty. There are certain areas where, yeah, it'll work no problem. Other places, it's going to be tough and, more fight than it's worth, so that's kind of my take on it. Residentially, it does kind of scare me a little bit, I just don't want it taken as, hey, we can do this, so now we're going to do it everywhere. No,
I don't have a good sense of the political landscape here and how these decisions would be made, so I'm not going to comment too much on anything related to that. The only thing I can suggest is, the 500-foot mark seems obviously reasonably applicable in most places, and then where the flexibility to go deeper, but it might, it might be that to go deeper, right now, I think the permitting process to go deeper is incredibly tough and has a lot of requirements. That's the part that I can see being adjusted to say, look, you can go deeper, but the requirements are maybe a bit more than 500, but they are not necessarily what is required today. So that there's a change in the type of approval process to go deeper, which would allow, maybe the call it the professionals, right? The experts that need to come in to assess whether that's safe or can be done, can be brought to bear. But I can see that there would be benefit being able to go deeper, but obviously to just leave it wide open and leave it up to anyone, maybe it has its concerns, of course. So I think there is some medium ground in there to go deeper, but with some rationale to allow that and control that.
I think we have a couple minutes left. Any other questions? Comments? Concerns? Bad jokes?
They want to see a magic show.
I think they want the magic. Well, we'll wrap it up. Obviously, we're about to go into happy hour, mix, mingle, have fun. Continue these conversations. Interact with each other. Find out, what makes sense, what doesn't make sense. And just, that's the key piece, the key takeaway for me. For experts, we don't have an answer.
If we were to go to 850, does that change the loop size? Are we going to be stuffing 2-inch loops down 850 foot holes, or inch
I did want to add to this. So one of the things, of course, and I think this was mentioned earlier, that going deeper is going to require different heat exchangers. And you know, depending on the engineers in the room here and how much pressure loss they like to deal with in terms, but we know that pumping power is a parasite that we want to get rid of. So the deeper you go, the larger the loop that you're going to have to use, which means larger boreholes and so on. Or, you know, you got to go, basically you need bigger flow path to get the higher flow rates you need to get the more capacity. So there is definitely some sort of standard lengths that we're seeing. 600 or 650 is great for 1.25 inch in the type of rock that we're having in New York. When you get into granites, maybe it's a little shorter because you got more capacity. And then 850s seem to be great for 1.5 inch. You go past 850, now you really need to be stepping up your pipe size to the next size, so that, which is, if you can see some of the loops outside here, 2 inch might be the next size. Well, now it's a huge jump in size, and then you can maybe go to 1,200 feet. But I mean, that's a totally different animal, and that'd be a bigger borehole at that point. You're looking at going to 6 inch minimum from maybe a 5 inch, and so yes, all this. Well, 1.5 inch you can do with 850. 850s, sorry, you can go to 850 with 1.5 inch.
I just don't want people in this room to think it's cheaper to go to 850.
Well, that's the other point I think is important to make here, that going deeper is potentially cheaper, and we always run the math on ours when we compare. Some of the main reasons why it's possibly cheaper is if you're in good drilling conditions like shale or whatever, or shale and limestone, something you can drill fast, and you got to run an awful lot of casing to get to rock, so you're maybe 200 feet to rock. You already invested a huge amount of money in getting your casing to rock. It might make sense to make that hole longer and go to 850 instead of 650 or something, or 500. So it's really, it should be informed by capacity, which of course sometimes you need the capacity to, you know, you got to go deeper to get enough capacity. The other one is the cost factor, but it should be an informed decision on cost, and so you do some value engineering on whether a 500 footer or a 600 or 800 footer are lower cost. It's not an automatic slam dunk that it's lower cost, that's for sure.
Anything else? Going once? Twice? Sold. Oh. Thank you. Thank you, guys.